Hey everyone, welcome to ALB programming lesson. Did you notice that when you use SMPP transmitter to send SMS, the length of short message is not allowed to be more than 255? So what should we do if we need to send larger messages? There are two approaches. One is to use message payload, which is the focus of this lesson. The other is to use concatenated SMS, which is the focus of next lesson. So what is message payload? Let's find it out in the SMPP Protocol spec. Here's the spec. Let's take a quick look at it. Let's search message payload. I've got 32 results. The first result is in the table of contents. Let's click here. This is a section exclusively on the message payload. It says message payload contains user data similar to short message. Its advantage is to carry more than 255 bytes of data. If your application needs to send such a long message, then you need to use the message payload TLV. By the way, TLV is tag length value. Tag length value. When you use message payload field, you need to set the SM length to 0. In implementation, all you need to do is not use the method setShortMessage. This table will be helpful during the implementation. Let's see what else we can learn about message payload. Here it says message payload can replace short message. Talking about the same thing. It's still talking about similar stuff, but in the submit multi PDU. Next one. Alright, this table lists a bunch of TLV parameters and explains what they do. TLV is also known as optional parameters. Let's see. Message payload contains extended SMS data. Its limit is 64K. Well, compared to 255 bytes, that's huge, right? But it is always better to keep your message short and clear, nice and simple, no matter how large the system can support. Another thing is short message and message payload is either or. Either short message or message payload. They cannot be set at the same time. If you use message payload, then you have to make SM length 0. It says data SM, not the focus of this lesson. Let's see the next one. This one, we already mentioned it. It's talking about the short message fields. Its limit is 255, theoretically. The actual limit depends on the underlying network. This is very important. Next one. Already explained it. So next one. Here it's still talking about the limit of message payload field. Next one. It's in the context of replace SMPDU, which is not the focus of this lesson. Next one. This whole thing is talking about what message replacement is. Let's skip it. Alright, this section is about command status error code, response code, these sorts of stuff. In the 6th lesson, we already learned the concept of communication between ESME and SMS sender. ESME sends a request to SMSC, and the SMSC sends a response to the ESME. The response PDU has a field called command status, which indicates whether the request was successful or not. If the request is successful, then the response will be this ESME response OK. If you get a response like this, response invalid message length, there might be something wrong with the short message field or message payload field. They might be either too short or too long. Next one. It's talking about data SMPDU. Let's skip it. This one. It's important. It's related to user data header, which is used in the concatenated SMS. We'll talk about it in the next lesson. Alright, this section is about short message field. Here it tells us the limit and tells us to use message payload if we want to send larger SMS. Next one. This section is about short message length and explains what it has to do with message payload. Next one. In this table, you can see a tag of message payload, but don't get confused. The tag and value here is different from TLV tag value. This tag means tag name or field name, such as message payload. And this value is the same as TLV tag, like 0x0424. Next one. We're back. Next one. Alright, that's it. Let's see the implementation. Let's start from the cloudhopper transmitter, which we've learned in the 10th lesson. After that, we will see the implementation in opensmpp. Let's see the Java project. The source code is here. Remember, our goal is to send long SMS or large SMS. So let's compose one, something larger than 255 characters, then replace this one. We see the amount of characters in this area. It says selected 256 characters. Why don't we copy this text and replace the message content? Now I've got a long message. We're gonna send it out with message payload. So let's change the implementation details of this method. I've been using this method, setShortMessage. Now we're gonna use another method. Set optional parameters. This one. It takes an argument TLV. Let's define one. Import this class. There is an error. Eclipse suggests a quick fix. It works technically, but I have no idea what arguments I should pass in. So I'm gonna take a look at its definition of this TLV. Hold the control button on your keyboard and left click on TLV. Well, I can find the declaration of this constructor. That will do. Now I know the first argument is tag, the second one is value. Remember, we already found out the tag of message payload in the spec. Here is it. It's a constant and tag being 0x0424. stands for message payload. Let's copy it. Tag is the first argument and the data type is short. The second argument is value, which is a byte array. Here, the program is actually doing the conversion, converting this string type short message into byte array. So let's copy this one. All right, have we done yet? Actually not. The spec tells us to set SM length to 0 if we use message payload. See? When you write your code, all you need to do is delete this method and not call it. Save the file. Now, the implementation is pretty much finished. If you want to do some tests, then you need to download a couple of tools. One is SMS Recipient Simulator. The other is a new version of SMPP Sim. Both of them are on my GitHub page. Here is the link. Let's do it. Let's start from the SMPP Sim. This is almost the same as the SMPP Sim that we introduced in the previous tutorials. I've changed something on the basis of the original version. In the 12th lesson, we will compare the two versions, but now let's go to the release. In this tutorial, we'll use this version 3.0.0. Click here and download will start. Download's finished. Let's find it out and unzip it. This is a new version of SMPP Sim. It has exactly the same usage as the original one. This one, Start SMPP Sim, is how you start SMPP Sim. Before connecting transmitter to the SMPP Sim, I need to check some configs like IP address. Since I'm testing on a local computer, I change it to 127.0.0.1. Port, system ID, and the password also have to be consistent with the settings of SMPP Sim, which you can find in the conf folder. Here. Here is the SMPP port. Here is system ID and password. By default, these are already configured as what I've just said. Save the file. Alright, we need one more tool, SMS Recipient Simulator. It's also on my GitHub page. On the repository, this one. Go to release. In this lesson, we're going to use the very first release. Click here. It's downloaded now. Let's unzip it. This is the SMS Recipient Simulator that we're going to use. But before going any further, we need to check some config. Let's see this one. Alright, look at this phone number. It simulates the recipient's phone number. we need to make sure the sender sends to the correct number. In other words, this and this has to be the same. By the way, make sure these properties are consistent with those of the SMPP SIM. Before continuing, make sure you read the warning carefully. Alright, the default config ensures that the simulator connects to the SMPP SIM. We started with this batch file. This is how it looks like. Hit the enter key on your keyboard. Then you see a line that says SMPP receiver is connected to SMSC. This also implies I can test my transmitter. Let's run this program right now. Here. As always, the program binds to SMS sender, submitted the message, and exits. At the same time, the SMS recipient simulator also received a message here. You can also verify whether the content is what you expected by checking the log file here. This is the latest log file. Let's copy the received content. And paste it here. This is the content that I've received. This is the content that I've sent. They are the same. Alright, this is pretty much the implementation with cloudhopper SMPP library. This is a Java project that you can start. Let's see the implementation with opensmpp. Let's start from this Java project. Let's modify source code. Maybe we can change the IP address here. These configurations are by default consistent with SMPP SIM configs. Save the file. Run the program. We can see the message in this program is already submitted to the SMS center. And take a look at the receiver. I can't see anything received. Remember, SMS recipient simulator has a number and it only receives the messages that belong to it. So actually I need to send to the number of the recipient. I'm going to replace this destination address for this one. Save the file and run the program. Let's see. This time, receiver gets the message. Next, I'm going to replace the message content in the transmitter. Then, similar to the cloudhopper transmitter, I'm going to replace this method. I can use either this method or this one. I use this one. It takes an argument TLV, so I'll make an instance of it, like what I've done in the cloudhopper implementation. Import the TLV class. Oops, I've got an error, which is cannot instantiate type TLV. Let's take a look at this definition. Hold the control button on your keyboard and click on TLV. I can see the definitions of class variables here. And this line is a class definition, and we can notice this is an abstract class. We cannot directly instantiate it. Let's use other method. Let's call this one. Double click on it. It takes two arguments. The first one is tag. Data type is short integer. The other is data. It is a byte buffer. You know the tag, right? It's written in the spec. The short message data, it's supposed to be a byte buffer, but what I have right now is just a string. So let's create a byte buffer variable that carries our short message data. Import the class. Then we call the setBuffer method, which specifies the short message data. Let's take a look at this short message variable. It is declared here, and it contains our short message text. It's a string type variable, but this method takes an argument of byte array. See? Then I use getBytes method to kind of convert the string into byte array. Let's pass in the message data. Remember to delete the method setShortMessage. Save the file and run the program. Something's going wrong. Let's see. Finally, the program throws an exception. Let's see. This line gets a null pointer exception, so the response is null. So the message submission here wasn't successful. In the SMS center, there is an array out of bounds exception. Actually, this is because current SMPP library doesn't properly handle message payload. We have to change it. First of all, let's find out the current library in the Java project. Here, take a look at this package. It's com.logica.smpp. Let's remove this from the build path. Then we need a new library, which you can download from this link. It's downloaded just now. I'm going to put it into my project. Drag and drop. Copy files. Then I'll add jar into the build path. Then I need to fix all those imports in my code. I'm going to delete all the imports here. Now I import session class. Make sure you import the right package. Here are two classes called connection. Import this one. Alright, save the file. Get the receiver ready. Run the transmitter. Okay, now the message is received. Now I want to double confirm the message payload is really working. I'm going to change the message content. Add a hello. You see, the recipient also got one with hello. Now why don't we check the log as well? This is the latest content with hello in front. You can compare the date time also. That's pretty much it. We've learned in this lesson the SMPP parameter message payload, along with the implementation with cloudhopper SMPP library and with opensmpp library as well. If you use opensmpp, remember to use the right library. In addition, I use a couple of other tools that help my testing. One is SMPP recipient simulator. The other is SMPP sim with bug fix. It can process the submit SMPDU that carries message payload parameter. That's it. Hope you've learned something. Thanks for watching. See you in the next video. Peace.